Hey everyone, welcome to part 3 of our study guide. We were looking at our chapter 9 study guide and we went over simplifying using square roots. We went over using complete the square, and we are finally now in using the discriminant and the quadratic formula to identify solutions. Let's start off with problem number 14. And in this one, it's asking us how many real solutions, and it does say real solutions, does the equation have. In order to solve this, we don't need the whole quadratic formula. We really just need the discriminant, and the discriminant is equal to b squared minus 4ac. If it helps you, and I think it's a really good idea, if your equation is already in standard form, go ahead and label your a, b, and c. And let's go ahead and plug those in to our discriminant. This is going to end up being b squared. We see b right there is 5, so we'll have 5 squared minus 4 times a is 1, c is -2. And you could go ahead and throw that into your calculator, but I think I'm going to multiply this by hand because 5 squared is 25. I see a negative here and here, so I know that's going to end up being a positive or a plus. 4 times 2 is 8. Bringing that together, my discriminant is 25 plus 8, which is going to end up being 33. With that done, I need to interpret that. And if you remember, if your discriminant is positive, so for the discriminant, let me go ahead and label it as D. So the discriminant is D. If your discriminant is positive, that's going to end up giving you 2 solutions. If your discriminant is 0, that's going to end up giving you 1 solution. And if your discriminant is negative, then you would end up with no real solutions. I have a feeling we're going to be looking at this a couple times in the next couple problems, but given our situation now, we could see that we have a positive, so we're going to end up with 2 real solutions. Let me space that out just a little bit. 2 real solutions. Let's take off from there. Headed down to problem number 15. Again, how many real solutions does the equation have? We can see we're already in standard form. And let's go ahead and label our A, B, and C. And let's plug that in too using the exact same discriminant expression. And I'm going to keep using what we did a second ago where we said D equals B squared minus 4AC. Let's plug it in. We're going to end up with the discriminant is equal to B squared is 2 squared minus 4 times A is 3 and C is 7. Now, I have a feeling this is going to end up a certain way, but let's play it out. Again, you could put all this into your calculator. That might save you a few seconds, but I'm going to go ahead and multiply it out. I'm going to have B squared is 4 minus 4 times 3 is 12, and 12 times 7 is 84. And that's going to be a very small number, a negative number. 4 minus 84, we end up with negative 80. Since our discriminant is negative, looking over at this chart here, and let's go ahead and highlight this in green so we can see it much easier. Since our discriminant is negative, we can see that we're going to have no real solution. So let's write that down as our answer here. We would have no real solutions. Let me make that S a little nicer. All right, let's take that and move on to the next problem. 14, 15, on to 16. Again, exact same question. How many real solutions does it have? Our equation is already in standard form. Let's make it easier on our brains by labeling A, B, and C. Moving into the discriminant equation, we're going to look for B squared minus 4AC. And let's plug it in. The discriminant here is going to be equal to B squared, or in other words, 10 squared minus 4 times 5 times 20. Let's play it out, see what's going to happen. D equals 10 squared is 100 minus 4 times 5 is 20. 20 times 20 is going to give us 400. And the discriminant is 100 minus 400, in other words, 300. And it looks like we have another negative discriminant. With another negative discriminant, negative means no real solution. So we're going to have that right here. No real solutions. And we'll drop that off there and head over to the next problem. That was 16. Let's go to 17 now. What is the correct setup using the quadratic formula? So guys, again, make sure you're reading their directions carefully. I don't want you to head off into a problem and do every single step. We really only want the correct setup. So let's start setting up. What we're going to need here in order to set up is you have to remember the entirety of the quadratic formula. Let's get that written down. We're going to have x equals, and it's a really good idea to write this down a couple times just to make sure you really have it memorized. Negative b plus or minus the square root of b squared minus 4ac. And that's going to be all over 2a. Just like we did in the last couple of problems, let's go ahead and label our coefficients of a, b, and c. And to set this up, we're going to plug in where b goes. And if it helps you, I'm going to go ahead and color code this a little bit. There's b is 7, so that's going to go in for b and b here. A is 3, and I see an a goes here and here. And lastly, we have the value c is negative 5. That's going to go in right there. If colors help you out, that's awesome. And if they don't even worry about it. Let's plug in what we need to do. So we're going to have x equals. I'm going to make sure I have a lot of space to write this down. And I'll go ahead. Negative b is going to start us off with negative 7 plus or minus. And we'll have then there the square root of b squared, or in other words, 7 squared. Let me make that 7 just a little bit cuter. Minus 4 times, and a would be 3. C is negative 5. All over 2 times a, in other words, 2 times 3. And in this case, we can see all of the colors that we had are there. We can see B is set up where it needs to go. We can see we have the A right there, and we have the C exactly where it goes. Not too much to plug in. I know the quadratic formula can look scary at first. The more we use it, the more we see the pieces of it, the easier it gets. And because we only wanted the correct setup, we're actually done with this problem. We could leave this here just like that. Let's head over to problem number 18, and that's going to be just up here. And this one is now asking us, use the quadratic formula to find the solution. Now, guys, I'm going to approach this a little bit different. If you like to set up like this, to plug in all the numbers and figure it out, that's awesome. I love doing it that way. If somebody gave me this problem, I would probably solve it that way myself. But I think some of us, at least from what you told me, a lot of us like to maybe chop up the pieces of the quadratic formula. So what I want to do here is, before I get into the problem, I want to go ahead and write down the quadratic formula first. So I'm going to write down x equals. And I know we wrote it down the last problem, but it's good to write it down more than once. It's good to have it memorized. X equals negative b plus or minus the square root of. And inside here would be b squared minus 4 times a times c all over 2a. And I want you to notice that the quadratic formula is really just 3 pieces. We have the negative b. We have everything inside the radical and the radical itself. And down below, it's all over 2a. What I'd like to do is I'd like to get those 3 pieces first. And then I'll plug them in. Maybe it's better to chop up the problem into little steps and make it easier for us. Let's see if we like that. So headed down here. Let me start with x equals negative b. And using negative b, I'm going to label my ABC here. So I know I have invisible 1 for a, b is 4, and c is negative 41. Let me try those here. So negative b is going to give me x equals negative 4. And I'm going to highlight that the same color as I used over here. So for that first negative b, I'm going to make it yellow. Then I'll go into the square root there. So let's do that next. So we're going to have the square root of, and let me see if I can make that a little bit nicer looking. That's better. B squared minus 4ac, or in other words, 4 squared, minus 4 times a times c, negative 41. And that'll give me the square root of, now this might be a big number here. What I'd like you to do when you get to a step like this, you can try it by hand, but maybe this is one of those problems where it's easier to use a calculator. So I already know from using my calculator that this inside the radical is going to come out to be 180. With radical 180, I want to break it up as much as I can. Let me see if I can find the biggest perfect square that divides 180. And it ends up being, let me see, I just want to double check. I think the biggest perfect square that divides 180 is going to be, come on, Desmos, come up, 180 divided by 36. And yes, I think it's going to be 5. So let's break it up. 36 and 5. But the square root of 36 can simplify, and that's going to become 6 radical 5. So our radical portion is there. Let me go ahead and highlight that in pink so I know where to put it later. And we could head down to the very last one, which is 2a, and really, really easy. 2a is going to equal 2 times a is 1, or in other words, just 2. And we can highlight that in, let me see, I want to make sure I get my colors the right way here. Oops. So I want to make sure I have this highlighted in the correct color is green, and this one's the one that should be in pink. Let's bring it together. So putting that all into the quadratic formula here, we're going to end up with x equals big fraction. Negative b is negative 4, plus or minus, and that big radical we figured out is actually just 6 radical 5. And down below it's going to be all over 2. You see how easy that was, guys? We didn't have to do very, very much here. Now, we're not done yet, but it did save us a lot of work on the side, which would have been all right here. Let's simplify this. So for the purple one, and you guys know purple means positive, we're going to have the fraction x equals negative 4 plus 6 radical 5 over 2. And the only thing I can think of to do here, without getting any decimals, of course, is we're going to divide negative 4 and 6 by 2. Let's divide both of those by 2. And that's going to drop us off with x equals negative 4 divided by 2 is negative 2. Plus 6 divided by 2 is 3. The radical 5 comes down for the ride. And that's going to end up being one of our solutions. In green, let's do the same thing now with the negative in between. And let's head down and write that. So we're going to have here for our second solution, x equals, in a fraction, we'll have negative 4. And again, this time we're using the minus. So minus 6 radical 5 all over 2. And we're going to end up doing almost the exact same thing. We're going to divide negative 4 and negative 6 by 2. And that'll drop us off with x equals negative 4 divided by 2 is negative 2. Minus 6 divided by 3 is minus 3 radical 5. And we have our second solution. As simple as it could be. Set to go. So again, for this problem, recap, we took the pieces of negative b, the radical, and then 2a all together, and we were able to use those in our formula here. Just organizing it, making it a little bit better. All right, guys, to finish off here, since we're here anyways, let's go ahead and handle the review for these last two problems. This is spiraling back from some of our previous exams, so you may remember how to do these. Let me handle these very quickly to wrap up, because we will see something like this on the exam. Looking at problem number 19, it looks like these two are multiplying. You may be thinking box method, and you are right. We need the box method here. Let me set ours up. So we have a box. We're going to cut it in half vertically, horizontally. And I know a lot of you don't. I've seen a lot of you multiply by using distribution like that, which is fine. If that's your way to do it, that's great. But if you're a little nervous about it, you want to keep things organized, maybe this is the better way to do it. I'm going to put 3x minus 5. So 3x minus 5y is going to go here. 3x minus 5y. And then 7x minus 6y can go here. 7x minus 6y. And we could start multiplying. So let's go. Looking at these two first. 3x times 7x is going to give me 21x squared because it's x times x. Next up here, I'm going to have negative times a positive is negative. 3 times 6 is 18. And x times y is exactly that, x, y. The same thing's going to happen in this box here when we multiply. Negative 5 times 7 is negative 35, x, y. And in the far back, we're going to have this times this to come into the last box. So we'll have a negative times a negative. It's positive. 5 times 6 is 30. Let me write that 3 a little nicer. And y times y is y squared. All that's left to do is, let's see if we can combine like terms. Bringing down our final solution, we'll have 21x squared, negative 35 minus 18. Let me bring up my calculator to make sure I don't make any mistakes. Negative 35 minus 18 is going to give me negative 53. So I would have negative 53 xy, and in the back, positive 30y squared. Now it's wrapped up, good to go. Let's head over to the very last problem here. So in our last problem, find the solutions by factoring. It looks like we would need to factor this. Let's take this in a few steps, guys. In case you forgot, let me lay out what our steps are going to be. Because this is not a 1, we're going to need to multiply a times c. That's going to feed into the x game. So we're going to have an x game right here. And again, because this is not a 1, from that x game, that's going to feed into the box method. So we are going to have another box method here, but it's going to be a reverse box method because we're going to find out what comes in. And from that box method, we're going to have, in parentheses, something equal to 0. Seems like a lot, guys, but when we start getting into it, it's going to make a lot more sense as we fly through it. So let's do that right now. Let's go ahead and multiply a times c, and that'll give us negative 48. The b, the middle number, goes in the bottom. And I'm trying to think of two numbers that multiply to give us negative 48 and add up to negative 2. What that's going to be is we'll have a positive and a negative. And I'm trying to think, what numbers give me negative 48, but they're going to add up to 2. What could it be? What could it be? If you can't think of these, guys, you do have your times tables available to you. You have your calculators available to you. And I'm not going to take a long time to do this because I already know that 8 times 6 is going to give me 48. I know that if I make it a positive 6 and a negative 8, it checks out. Let's check it right now. So let's see. 6 times negative 8, negative 48. That works. How about the bottom? 6 plus negative 8, it's negative 2. It works out. Now, you may have forgotten, okay, well, how do I use the box method for this? You're going to need your first term, the 2x squared. You're going to need the negative 24, and those are going to go in the very first box, 2x squared, and in the back, negative 24. The two pieces of your x game, the positive 6 and the negative 8, those are going to go inside the boxes with positive 6x and negative 8x. And our job is to figure out, okay, so then what numbers are going to go here and here, and what numbers go here and here in order to be able to fill in this and this. So let's figure out this box here. Moving in, trying to figure out what numbers multiply to give me 2x. And it looks like it was just going to be a 2x and an x. Let's see if that works. 2x can give me negative 8x. X can give me 6x. So let's keep going. Now I need to figure out x times what gives me 6x. It looks like it's going to be 6. That works out. 2 times what gives me negative 8? It looks like it would be a negative 4. And if I try to multiply the last two, negative 4 times 6, if it equals negative 24, it's good, which it is. So it looks like we have our two factors. It looks like we have what's going to go here and what's going to go here. Let's go fill in our parentheses here. So we'll have x minus 4. And in the second one, we'll have 2x, and that's a positive 6 right there. So it'll be plus 6. But this is still equal to 0. To finish this problem, we're going to need to use, you might remember me saying zero product property. If you remember, that's okay. Basically, what we need is we're saying if two things are multiplying and they equal 0, you're going to have to break them up into two different equations. The first one is going to be x minus 4 equal to 0. I'll go ahead and solve that now. If I do plus 4 to both sides, I end up with x equals 4. And one of my answers, one of my solutions is all the way done. And then I'll do the second one, 2x plus 6. Let's take that to 2x plus 6 equals 0. Let's go ahead and solve that now. We'll have minus 6 on both sides. That'll give me 2x, try not to write too small here, equals negative 6 divided by 2. 2's cancel. And I think we have our final answer is x equals negative 6 divided by 2 is negative 3. And we have achieved our final answer. All right, everybody, I'll be uploading these videos. I'll be uploading this document, these solutions to our Canvas page. So I hope you are hearing this. I hope you're seeing this. Don't forget, tutoring's available. I'm here for you, and we got this. I'll be seeing you soon. Bye-bye.